In this video, I'll show you how to quickly spot signal problems with the coherence matrix in DIRAC. After checking the setup, it's time to measure and then check the signal quality. It can be difficult, though, to spot all signal problems in test-based models, as there can easily be more than 10,000 different FRFs. But with the coherence matrix, you will spot them all and optimize the signal quality in any size dataset. Here's how. To check the signal quality of your measurement, select the Measured preset, set the matrix viewer to coherence mode, and average over the frequency range of interest. You can then increase the minimum value of the coherence until you see white areas appearing in the matrix. The white areas correspond to the FRFs with the lowest signal quality. If the whole matrix turns white at the same time, you have very similar signal quality in your data. If you're satisfied with the minimum coherence, you can move on to the next quality checks. However, if there are clear white patterns in the matrix, you have signal problems in the data that you need to react to. If you spot a white row when zooming in, this means that there's a problem with the sensor channel. So identify the sensor and check if there's a broken part in its measurement chain. If the matrix row is only partly white, this would be an indicator that the sensor fell off at some point during the tests. These problems you really want to spot as soon as possible, so make sure to check the coherence multiple times during your measurement. For example, after measuring the excitation points of every virtual point. White columns in the matrix indicate that the repeatability of an impact was relatively bad. So identify the impact and make some more measurements. If you cannot improve the coherence, you might need to consider moving it to a position that you can excite more precisely. And always remember to use the automatic measurement selection, as it will choose the most similar impacts for you. Symmetric areas of your system should have similar signal quality. If the blocks in the matrix corresponding to these symmetric VPs have different coherence, you can probably improve the bad one. If the coherence is low for the high or low frequencies, consider adding an input source with different hammer tip. When you use multiple input sources, also remember to check the coherence in the merging range. If the coherence drops in this frequency range, either the impacts with the two hammers were not similar and need to be repeated, or the cutoff and roll of frequencies need to be adjusted. Now you know how to make a coherent impact with DIRAC.